And moving on with the presentations. And now it's my privilege to invite Professor G Madhavi Latha to deliver her talk on Jute Geotextiles, a sustainable material. G Madhavi Latha is a professor and chair at the Center for Sustainable Technologies of IISc. Madam is also the chairperson, IGS Bangalore chapter. She pioneered the research area of micro to macro of soil geosynthetics interactions. Professor Madhavi is a primary geotechnical consultant to the world's highest railway bridge on River Chenab in Jammu. She is a member of the Technical Committee on Soil Reinforcement of International Geosynthetics Society. She is the first recipient of the Best Women Researcher in Geotechnical Engineering Award from IGS in 2020. She is a SERB POWER Fellow and listed among the top 75 women in STEAM of India. Over to you, ma'am.
Thank you. Good afternoon. Thank you, National Jute Board and Srivalsa for including me in this program. I have 15 minutes to convince you all that jute is a sustainable material. But I'm not doing it on the behalf of National Jute Board, but I'm doing it on the behalf of the Center for Sustainable Technologies at IISc. So many of you may not be knowing that there is such center existing at IISc, but I am proud to say that it is one of the oldest sustainable departments in the world. It will finish its 50 years by next year. It will be 50 years old by 2024. How it started? It started with a group of professors from IISc thinking a lot during 1974, where they have concluded that whatever they are doing, research is not useful for common man, particularly for critical mass of poor people living in rural India. So what they thought is they all have to come together to develop technologies which will enhance the life in rural India. So with that time, this center called Astra. Astra is a weapon against poverty. In Sanskrit, it is a weapon. So this center is started with the name of Astra, Application of Science and Technologies to Rural Areas. So the center grew very quickly. It has only 3 principles in the beginning. Number 1 is it has to solve problems related to the society. I mean, the problems have to be need-oriented, not like blue sky research what we do. I am very sad to say that most of the research done in today's world is blue sky research, what we call. To give an example, we have this research freedom in our institutes. Someone can develop drains to moon, drainage system to moon. No one stops him from doing that research, right? Another person can apply AI/ML to something like reducing laziness in primary school kids. Who stops him from doing it? But the research at CST, what we call Center for Sustainable Technologies, should be translational in nature, which means it has to have a specific objective of solving global problems. And then, most importantly, it should use resources locally available. People, it has to enhance the economy of local governance. So this was the aim with which it started. And it mainly, initial years, I'm not going into the details, but you will see a lot of information if you Google. It developed very simple technologies which changed the rural health and economy. For example, it developed the chulhas, which is smoke-free stoves for rural women, which are a big hit. Millions of such stoves are sold across the world. And many such technologies, agro processes can be dried through biomass gasification systems to electrify the rural villages. Many such things are developed. The center has encompassed industrial sustainability also in the over the years, and in 2004 it renamed itself as Center for Sustainable Technologies to represent both rural and industrial sustainability. Currently the center has a mix of people coming from truly multidisciplinary backgrounds: chemical engineers, civil engineers, chemists, environmentalists, policy makers, and many other people who together work on solving problems related to sustainability. And the center mainly works on 4 different domains. One is water, one is habitat, one is environment, and then one is energy. So This is my research. I have been working in the area of geosynthetics for past 28 years. I should say that is the number I counted. So never I worked on jute. To be very honest, my work was mainly on polymeric geosynthetics, and I always call geosynthetics as green, though they are polymers, because they have certain properties which make them sustainable. One is they reduce the usage of natural materials like sand and aggregates into construction so that we have less carbon footprint. And they also reduce the waste generation, and they have lower carbon footprint compared to other materials like cement and concrete used in civil engineering. So most of the countries and the United Nations have agreed that the geosynthetics are green materials, and in most of the projects abroad, use of geosynthetics is mandatory. So now, I have been working on these geosynthetics, but after I became the chair of the Sustainable Technologies at IISc, I started thinking how in research-wise I can contribute to this center. The thing that came to my mind is natural geosynthetics. So I contacted Coir board and then got some inputs from them, though not in the form of any projects, but I started working on Coir and developed some interesting relations between the liquefaction potential of soils and inclusion of Coir. And then, till recent times, I have not had any contacts with Jute, except that my phone had two contacts. One is Jute Chaudhary. That is, he keeps coming to all our IGCs and puts a stall where like we are very much intrigued by his dedication to his field. And other Jute Pragna, she lives in Malleshwaram. She supplies jute bags to our conferences. This is the only connection I had with jute. But recently I started thinking about working on jute geosynthetics, and I've ordered some amount of jute which is easy to get from Amazon. 500 rupees you pay and they gave me like 10 square meters of jute. I started working on the different problems. Maybe I will touch upon when I go ahead, but what I'm saying is, after Mahadev from Jute Board called me and kept me in touch, I started thinking more on this. Thanks for this workshop, which is an impetus for all of us to know more about jute geosynthetics and keep working on things that will promote this product. Now, this is an interesting picture of my grandmother. What you see is she is making jute ropes. This is about like 30 years old picture. I grew up seeing her making these jute ropes. She makes it in such a fine way, getting this jute which is based on gongura, what we call in Andhra Pradesh, very famous, Hibiscus cannabinus. She gets these jute fibers and makes fine ropes with her own hands. And at some point of time, most of the people in my village were using the jute ropes made by her too. These are used for making cots. And this is the best way I am connected to jute. And I also realized in today's inaugural function that my year of birth matches with the year of Jute Corporation founding. So I have a birth connection with jute. So that makes it more interesting to me. And as everyone said, it's a plant-based material, biodegradable, leaves less carbon footprint. So definitely we all should go with it. But what I will explain in today's talk is how different sustainable development goals of United Nations are already a part of jute, right? Particularly 9 areas in which jute can be excellent product which promotes these sustainable development goals. The deadline for implementing this UN SDGs is 2030. So if all of us start working for the next decade on jute-related problem-solving approaches in civil, any other engineering, then definitely we will take several steps ahead in this direction. So I will go with the first one, UN SDG 3, where we have good health and well-being. Obviously, jute comes from a plant-based product, and then you make jute, and then it gets biodegraded, and you grow jute again. So it's a recycle, right? The circularity is established there. So it doesn't leave any trace of harmful substances into nature. So it's excellent for good health and well-being. And clean water and sanitation, Sustainable Development Goal 6. I was very interested to see how jute, actually I was doing a lot of research on various jute-related products and research happening across the world. There are patents on jute filters to be used in RO systems of our water filters. There are patents on jute-related water purification systems. So I'm not sure where we stand in our country in these areas, but definitely that is one area I think which contributes to the clean water in a very sustainable way. And sanitation, IIT Kharagpur is ahead of us. The medical school is doing a lot of research on how to use jute for developing sanitary napkins, which will solve a big problem of health hazards. So much of waste generation, million tons of hazardous waste. That will be stopped if we take it forward and make it more comfortable, more convenient for usage. And then decent work and economic growth. I have told you my grandmother was an independent jute worker, to be very honest. So it can start from one person to, it has big factories, it has groups, small local groups which work on jute cultivation, jute making, jute rope making, jute geotextile making. So definitely it provides decent work to many rural people, including women particularly. Jute bag making is a big industry now in the country. So this is definitely contributes to the SDG 8. And then this is more close to what we do. This is industry and innovation and infrastructure. So as all of us have already seen in today's many presentations, jute is solving many problems related to civil engineering. Most importantly, one is they are called soil savers because they protect slopes, they protect soil erosion, they provide solutions for soil erosion in a very simple residential plot to big slopes. What you are seeing is a slope stabilized by Jute Geocells. Geocells is very close to my heart. It is my PhD topic at IIT Madras. Recently, I have submitted a project proposal also to UGC Aspire on Jute Geocells to stabilize slopes. So maybe in the coming years when I present, I have more technical details to present on that. And then PVDs are one excellent example where we can take jute into next level because the biggest problem with the jute is it may not be able to take creep. But in applications like PVDs, you don't have the creep effects. The only thing what you need is a filtration and drainage and then sucking of water, for which these fibers are excellent. You can mix coir and jute, what I have shown you. Coir can be taking the role of polypropylene in your PVDs, and jute can be the non-woven geotextile outer layer. So this combination can work wonderfully, which we need more details on this. And of course for road stabilization. Little more onto the innovation what we can bring into the research and application of civil engineering through jute. What you are seeing is different types of jutes. Recently, I have developed this area of soil, sand and geosynthetic interactions from micro to macro level. I'm very much interested in this topic. What we do is the shape and size of the particles, how they contribute to the interface shear strength, which is very important for any reinforced soil structure. We realized that the particle size and the aperture size have a thing to go together. The combination, if you can solve, you can definitely make very perfect reinforced soil structure. So the advantage with jute geosynthetics compared to the regular polymeric geotextiles is that you have the creative freedom to customize jute into any kind of aperture, and also the apertures in jute are not rigid, they are flexible. So they actually allow the movement of the soil within their apertures so that you have more interactions developed between the layers. I am thinking this will be an excellent way to go forward if you are talking about research at micro level. I am showing a picture from my own study where I have shown that different sized particles and different aperture sizes, how it gets contributed to the overall strength. This is a well-published research, but the only thing we can add here is going forward, I can include jute into the research and see how better you can develop these combination products. And then I have more research ideas like, they are at the development stage. One of the things I'm working recently is on geosynthetic clay liners, where you have bentonite clay sandwiched between a non-woven and woven geotextile, placed in liners or covers of any landfill. The biggest problem in these systems is that if the bentonite gets hydrated, it actually comes and forms a slimy layer around the soil and reduces the interface friction so much that there is no strength to sustain and there will be stability issues. I am looking at jute as a perfect solution for that, because jute has this water absorption capacity. So it can definitely take all the water and then make the bentonite slightly less hydrated and keep the shear strength intact. But the reason for which this actually needs little more exploration is jute is biodegradable, and when it comes in contact with water, there will be microbial growth and other processes which will accelerate the process of degradation. If we can develop technology by which we can retain the water absorption at the same time make it less biodegradable, it will be an excellent material for this GCLs. And also, in my liquefaction resistant experiments, I have seen that a material like non-woven geotextile provides excellent resistance to liquefaction, because compared to any other grid or polymeric geotextile which is woven, because it has the energy dissipation properties due to deformability, flexibility, and also it can sustain the pore pressure development for long cycles. So this I have actually, it's a published research from my group. But if you have jute, which is actually coated, this is a well-developed research already, coating of jute fibers, but if you use sustainable materials and provide coating and use it without losing the deformability, then it will be a way forward for providing earthquake-resistant retaining walls and embankments where lateral spreading can be arrested. And why I'm discussing these research ideas, people can write projects on this, because the research on any topic can be undercover, basically because plagiarism issues, patents and things. But I believe research on sustainability should be open. Everyone should work on it so that our next generations can be sustainable. And then SDG 11, sustainable cities and communities, you can see the amount of waste dumps. So jute can definitely come in favor of developing sustainable cities, because we will reduce the usage of plastic if you start using more jute into our lifestyle, so that the waste generation and waste management problems can be solved. And then UN SDG 12 on responsible consumption and production. I already told you, by usage of jute, you will reduce the usage of natural materials of, like sand. Sand mining is a big threat to our world now. The use of natural materials going forward, we will not have any of them because they are depleting very fast. So if you can use these kind of materials which are natural, at the same time reduce the usage of these aggregates, you reduce the transportation costs, you reduce the mining, and it will be definitely helpful for towards responsible consumption. And most importantly, net zero. Net zero is something which is actually gripping the world now. We do not want to produce any waste. We want to be self-sustainable. In that context, jute becomes a very relevant, because we leave zero waste in the soil. It becomes a part of the soil after it gets degraded. And then climate action, which is one of the most important things the world is looking at. What you're seeing in the picture is the NASA's 2022 image of April, how the heat waves are gripping the world. You will be alarmed to see that India is shown typically literally black. So going forward, we'll have more frequent heat waves, higher temperatures, and it is projected that it is actually, I didn't believe when I heard or studied about it, it is actually confirmed by the biologists and atmospheric ocean sciences of our IISc that by 2040, we will not be able to grow crops in the normal way what we are doing, particularly in India and southern part of the India. So this becomes a big concern for all of us, and we at Sustainable Technologies are looking at ways of doing smart agriculture. The institute has kindly granted us a group of people who are working in these areas to work on sustainable agriculture. We have a campus which is few thousand acres at Chitradurga. So a new initiative has started where we will grow crops in a way to make them sustainable to heat waves. So there are groups which will give us projections on the climate, how to control climate. There are groups which work on AI/ML project, drone-based cultivation, pesticide reduction, all those things. So it's a big corporate social responsibility of IISc which is being done at Chitradurga shortly. So here I see that jute can be one. We are looking at different kinds of species which we can grow at our campus and see like how sustainable they will be in the future under heat action. So definitely I can think that it will provide proper intervention into climate action, because jute is a natural material and it can actually, it has the tendency to cool the atmosphere. As we all know, it releases a lot of O2 and absorbs a lot of CO2. So this definitely contributes to the climate action. And interestingly, even under life below water, I have seen the presence of jute. There are papers published on how jute can be used as food for fish. Right? Jute is already a part of food for fish. So that is actually life underwater and aquaculture. And also I have seen some papers which talked about jute can reduce arsenic content in water and provide protection to aqua life. So in these ways, it's also contributing to life underwater. And life on land, definitely it has many properties which makes it sustainable on land. Because I have a very interesting observation is, if you have a wasteland, you won't be able to grow many different types of crops. But once you grow jute, it is very sustainable on wasteland. At the same time, it cleans the wasteland and you can grow other crops like rice immediately. This is one thing which I was very much interested in. And then it also cleans the atmosphere. It releases a lot of O2 and its water footprint is low. This is very interesting, because cotton, which is a very normal textile what we use, natural fiber, uses most of the water from the world. So if you can actually replace some of the cotton with jute, now jute has entered the fashion industry, we know. Jute is being worn by many models in the ramp walk. So jute can actually become a replacement to cotton in many ways, reducing the water footprint. I think that's about it. Thank you. I hope a little bit of convincement is done.
Thank you, ma'am. Now the session is open for interaction with the speaker.
Can you just throw some light on the replacement of jute for cement and aggregate?
Yes. Because, for example, if you look at road cross section, you have sub-base, base, and then surface, cores, and all that. So if you do not have any reinforcement, typically you will have a certain thickness for these aggregate layer and base layer specified. Right? If you use reinforcement, what exactly happens is it provides additional tensile strength. So the load is actually distributed over wider area, and also it reduces, because it provides lateral confinement, it reduces the amount of thickness needed for each of these layers, so that the same amount of load bearing capacity can be achieved by lesser thickness than in the normal circumstances without reinforcement. So that reduces at least like few centimeters of subgrade the layer thickness, which adds up to our material savings.
It can reduce the use of...
Yes, it is proven that it reduces.
100% replacement.
It cannot be 100%, because unless you have soil, there is no friction developed. Soil and reinforcement in combination works.
You were talking about the jute geotextile cells. Are they viable, like for using it for slopes and all? Do you think it's viable?
They are viable. They are definitely viable, because they are.
I think they are like made to order. They are not readily available.
You can make them.
Okay,
I think Srivalsa is doing a project where she is making jute geocells. It is nothing. You can. In fact, I am also started working on it. You just stitch two strips of jute to make these interconnected cells. The beauty of geocells is they improve the strength not by the material inside or material outside. By the configuration itself, it provides a kind of beam or membrane kind of support. So this outer jute layer need not be extremely strong, because it has a kind of hoop stress which is getting stabilized. Yeah.
But are they hand woven or they are machine woven like?
It can be anything. I mean, there's no, it can be anything. They are also available machine woven.
Oh, thank you.
Tape. It is called tape. Tape cloth can be used here.
Yeah.
Very effective. Yes.
I would like to recommend that Dr. Madhavi Latha should be made a brand ambassador for jute.
Thank you.
Yeah, just wanted to ask. Sorry?
Jute Latha.
Jute Latha. Yeah. On the aspects in terms of looking at jute for geotextiles for earthquake engineering, what are your suggestions in terms of looking at slope stability as well as other forms where the earthquake engineering solutions can also help in NBCC, CPWD, and other institutions which are actually doing even mass housing programs?
Yeah.
Can you kindly elaborate on that?
Yeah. My research has started just now in this area, but what I have seen is, in earthquakes, most of the times the major damage is due to liquefaction. And liquefaction happens typically in granular soils under water. Right. So when we use jute, because you are using it with sand, it is less biodegradable, unlike in clay. So definitely this kind of material will work very good for liquefaction mitigation. And I will have concrete results on this by the time next time Jute Board organizes another conference. Yeah, next year I will present typical evidence for that. And apart from that, slope stability also, if you use something like geocells, they are perfect because they need less strength of materials. They don't need really strong polymers. So we will have results to prove this in the coming years.
Maybe they are also more ductile because of this.
Yeah, they are extremely flexible.
Confinement pressure can be taken care of.
Another important thing is they have a texture. If you take grids or the textiles, polymeric, they don't have typical texture to increase the interface strength between soil and reinforcement. But jute has internal structure, particularly coir has higher texture, but jute also has texture. So it helps in absorbing these soils onto its surface, so it gives more interface shear strength. This is what I have seen in my preliminary studies. Yeah.
Madam, I think I am really astonished the way you have gone into the subject. As you know, technical textiles is what is coming up now. And as you know, I think I just wanted to share an idea with you. Basically, jute geotextiles are being used in ocean engineering. In ocean engineering, when I say for building bridges and all that, they're using a lot of jute geotextiles. But that's a very technical product where they will have to calculate the load bearing capacity and so on and so forth. And I think this is one area, as you are going really deep into jute, I think this should be one of the areas where I just want to suggest. And with regarding the geocell, so it's being used in a big way in the coir industry.
Okay.
It's already there, and that's what I'm saying. Thank you.
Thank
Very
you.
informative, very informative.
Yeah, I have seen a paper where people have used jute fibers to increase the setting time of concrete. So actually it can be transported to long places without it getting set. It also doesn't reduce the strength. So
It goes down deep into the ocean. I think it's very interesting.
Yeah. So
Ma'am,
Any work on the reinforced earthworks? Any study like you use the reinforced?
lot of papers are published.
But,
Jute board should
I
have
don't.
also.
In India, is any RE wall has been constructed with
I
jute?
think they should be able to.
Because that area we have to explore. That is a very, very important. We are using lot of synthetic material, all flyovers. So if you are able to replace, there will be lot of economy, and then the properties of friction and all. If you are able to get cost economy, then sustainability.
I will write a
think
project. Let
yeah,
them
that is very, very
sponsor
important
it.
area.
We'll take it forward. Yeah.
You like to mention that indicate this retaining walls, the walls.
Reinforced earth walls, approach flyovers.
RD wall.
I've done
I
a lot of work on this using synthetic polymers.
Yeah, then we have to
So
replace.
now
able to
we
do
can
it.
go ahead with the jute and see
jute,
how
jute,
much
yeah.
it can.
Then all cities, we have number of flyovers are being built now. So if you are able to prove that technology that is a good invention, and people economy is also, then sustainability, it adds societal things. Yeah.
Thank you so
Ma'am,
much.
I have only two questions to you.
Shall we discuss over the lunch? Because I think they are getting late for the thing. Sorry. We'll discuss during the lunch time. There's one more presentation.
Thank you, ma'am. It was definitely a fruitful interaction. And I request Professor G.L. Shivkumar Babu to present our token of appreciation to Professor G. Madhavi Latha. And thank you, ma'am, for enlightening us on the sustainability aspects of Jute Geotextiles. We are grateful for the time and effort you took to share your novel thoughts and experience with us.